Let's take a look at today's learning contents. Today's lesson allows you to understand pumps, learn about inspection procedures, and explain the overhaul of air valves and value reducers. It also helps you to understand the function of a central control room in a water treatment plant. Now then, shall we start learning? Let's learn about the definition and use of a pump. A pump is a mechanical device that transfers energy to a fluid by means of pressure to either extract fluid or push it out. The pump is used in waterworks to move a fluid from a lower place to a higher place by applying pressure and speed to the fluid to flow it into a pipe with an impeller or a piston. Let's learn about pump design and operations. There are several standards when we talk about the various classifications of pump types. Generally, however, pumps can be largely divided into turbo, positive displacement, and special types. The turbine pump is derived from the turbo engine of the Boeing company in the United States, and it is characterized by momentum transfer that occurs as the fluid continuously passes through the moving blades to ensure that pressure and flow rate increase in proportion to the number of rotations. The turbo pump can be classified into various types, including the centrifugal, mixed flow, and axial types. Let's learn more information about them all. The centrifugal pump is divided into single suction and double suction types according to the number of suction ports. The single suction pump collects the water flowing from the radial direction in the vortex casing to be led to the pump outlet. The double suction pump refers to the type in which the suction port is made on both sides with its impeller pair arranged back to back. The double suction pump provides twice the flow rate of the single suction pump and is generally used in large plants. It is noted for its efficiency. When classified according to the presence of a guide vane, the turbine pump has a guide vane at the impeller outlet, where some of the kinetic energy of water is converted into pressure energy, while the volute pump has no guide vanes. Therefore, the turbine pump is preferred when high head is required even with the same flow rate. A single-stage pump has only one impeller, while a multi-stage pump has two or more impellers. The multi-stage pump is used for a high discharge head when the flow rate does not increase. The centrifugal pump has a rotor, which rotates at a very high speed. It is used for a high flow rate and head. When compared to other types, it is light, requires a small installation area, exhibits high efficiency and low pulsation, and ensures easy handling with its simple structure. In addition, it has a low specific speed and a gentle slope of the flow rate head curve, and is therefore suitable for an area with large flow fluctuations, as there is a small change in the head even with a large flow rate fluctuation. And any shutoff operation is not possible because the shutoff head is formed after a certain amount of time has passed following its operation. In other words, the flow can be transmitted only when the discharge valve opens after a certain amount of time has passed after the pump operation. The centrifugal pump's impeller shape has a low specific speed and is therefore used in places where the head is relatively high and the flow rate is low. For this reason, centrifugal pumps are mostly used to collect water from a low place in waterworks and transmit them to a water treatment plant located at a higher place. The mixed flow pump is convex in shape and has the intermediate characteristics of centrifugal pumps and axial pumps as shown in its operating principle that the water flows in the axial direction and then flows out obliquely. The action of the impeller is governed by centrifugal force and lift, and its shape is similar to that of the axial pump. The mixed flow pump is advantageous to a wide head range, and its cavitation performance is superior to the axial flow pump. In addition, the range of power change according to the flow rate is small, and the shut-off operation is possible. Because the mixed flow pump has all the characteristics of centrifugal pumps and axial pumps, it is wisely used in waterworks and sewage treatment plants. It is also used for water and sewage services, cooling water circulation, agriculture, and dock drainage. Next, let me show you the operating principle and structure of an axial flow pump. The pump is cylindrical in shape, and the impeller vanes are large and wide and are shaped like the blades of a fan. Let's take a look at the features of an axial pump. First, the axial pump provides high flow rate and low head and is suitable for high-speed operations because of its small size. Though the small size is bad in terms of efficiency, a large-sized axial pump is much better than a centrifugal pump and helps to reduce the operating power costs. This means that the foot valve and discharge value can be omitted. More than this, it has a simple structure and is easy to operate and is economically viable. In addition, the axial pump has little flow rate change and efficiency degradation due to head change, and it is suitable for places with large head fluctuations because there is small change in the flow rate even if the change of head is large due to its high specific speed and steep slope of the flow rate head curve. At the point of the shut-off flow rate, the head is almost infinite, which allows for shut-off operations. That is, the flow can be transmitted as soon as the pump operates. Therefore, the axial pump should be started with the valve fully open. Lastly, pump overloading occurs when the transmitting flow is less than the design flow rate point. Therefore, when the flow rate is below a certain level, it is required to bypass some of the discharged flow rate to protect the pump from overload. The centrifugal pump's impeller shape has a high specific speed and is therefore used mainly in places where the head is relatively small and the flow rate is high. For this reason, the axial pump that provides a high flow rate at a low head is mostly used in sewage treatment plants and rainfall exclusion chambers, and it is used for circulation of a steam turbine condenser, which requires higher flow rate compared to the head, agriculture, sewage systems, and rainfall exclusion chambers. Next, let's talk about a positive displacement pump. The positive displacement pump uses a space where the displacement body periodically increases and decreases, and it sucks a certain amount of fluid while the displacement body increases and discharges the fluid while the displacement body decreases. The flow rate is proportional to the number of rotations, but the pressure is almost constant. The flow rate of the positive displacement pump is proportional to the number of rotations, but the discharge pressure head is determined by the tension of the spring set in the discharge valve or the weight of the fluid at a vertical height in the upper pipe. Therefore, the positive displacement pump has a certain characteristic without regard to the number of rotations. Let's learn more about positive displacement pumps. The positive displacement pump comes in various types. The piston pump is the oldest pump type with a piston that reciprocates inside the cylinder. It is a double-acting type in which two or more pumps are used, or an air chamber is installed on the discharge side because it gives intermittent discharge. In addition, it exhibits better suction performance than the centrifugal pump and is therefore used for water supply to oil boilers or in places where high pressure is required with a relatively small amount. The plunger pump is a type of pump that moves a plunger similar to the piston in the cylinder to pressurize and supply water. It is driven by steam or electronic motors, but is often powered by the electric motor. In addition, the plunger pump is suitable for high-pressure application, unlike the reciprocating piston pump used at relatively lower pressure. It has two types. One where the plunger moves in a horizontal direction from the left to the right, and the other where it moves up and down. The one in the figure corresponds to the former. The diaphragm pump is a type of positive displacement pump that sucks and discharges fluid by means of the movement of a diaphragm. The pump shaft works in connection with the movement of a motor, and the diaphragm pump creates suction when the shaft moves towards the motor and discharges when it moves toward the diaphragm. The gear pump uses the action of two identical and interlocking gears to deliver fluid. In addition, it is lightweight and has a simple structure, and there is no need for a valve because it is designed to prevent backflow. The vane pump contains several vanes inside the casing into which the rotor is inserted. It draws the fluid from the inlet and moves it to the outlet as the vane rotates. Through this method, the fluid that enters between the vanes close to the inlet is contained in the space composed of the vanes, cashing, and rotor, and is discharged via the rotational motion, when the fluid sometimes flows back into the gap between the tip of the vane and the inside of the casing. This is mainly used for hydraulic pumps and is also used commonly in machine tools and presses that need to change the direction of fluid during operation. The screw pump has 1 to 3 screws rotate within a pump casing and uses a principle in which the volume present between the casing and screw root moves from the inlet to the outlet. The screw pump is used to transport sewage from sewage disposal plants, sludge from sewage treatment plants, pulp from paper manufacturing industry, and solids from various plants. The tube pump transports a liquid to the injection point due to the compression of a tube using the rotary motion of a roller, and collects as much liquid as the roller space and discharges the collected liquid as the rotor rotates. Let's take a look at the structure of the pump. First, the typical pump used in a pumping station among water supply facilities is a centrifugal volute pump. The following is a disassembled view of the upper casing of the double-suction centrifugal volute pump. Water flowing from the suction pipe is sucked into the left and right sides of the impeller through the suction casing at the bottom. In this manner, the pump has a structure that sucks the fluid from both sides and is thus called a double suction pump. The bottom suction casing serves to stabilize the flow and keep the flow velocity uniform before water flows into the pump impeller, and the action of impeller increases the velocity head to pressurize the fluid to be transported. The pump shaft connected to the electric motor rotates, which in turn allows the impeller to rotate along with it. At this time, the sucked-in water is converted into velocity energy and discharged to the casing. And as the cross-sectional area of the casing is enlarged by Bernoulli's equation, some of the velocity energy is converted into pressure energy, thus forming the desired head. The pressurized water is discharged to the discharge casing, when some water may leak into the suction casing through the outside of the impeller in the process of transmission. To restrict the leakage flow rate, a ring is inserted into the outside of the impeller to minimize the gap between the casing and impeller, where the inserted ring is called a wearing ring. The water sucked into the suction casing is pressurized using the impeller suction port, but some water leaks out through the gap between the pump shaft and the casing. Sealing is carried out to prevent water leaks. Gland packing has been adopted. As the gland packing is fixed to the casing and the pump shaft rotates, heat is generated by friction in the packing part. Because it heats up the pump shaft and reduces the efficiency of the pump, cooling is needed. There are several cooling methods. However, in most cases, a pipe with a small diameter is connected from the top of the discharge casing to the packing part to circulate some of the discharged water for cooling. When the pump impeller fixed to the shaft rotates, a component is needed to support the weight and help it spin smoothly. The components playing this role are the bearings installed at both ends of the shaft. Now, let's learn more about pump casings. The casing holds the impeller inside and forms fluid passages at the front and rear impellers. The passage of liquid from the impeller outlet to the discharge port serves not only to purify water, but also to recover the velocity energy of the water from the impeller as pressure energy. The degree of this recovery efficiency greatly affects the pump performance. There are two methods to recover pressure. The first method is the diffuser type or turbine type. This is a method that forms an enlarged passage with a guide vein in the passage of the fluid at the outlet of the impeller to convert the velocity energy of the water from the impeller into pressure energy. The second method is the volute type. This method is to recover the pressure energy by decreasing the fluid velocity gradually in the volute chamber of the casing. Next, the casing can be split because it has an impeller inside. The split method varies depending on the model, suction, discharge direction, and pump size. In most cases, horizontal and vertical casing splits are common, but there is also the inclined split according to the use. Next, let's talk about the performance of the pump. The following diagrams show the characteristics curves of each pump for the head, pressure, and efficiency according to the change of flow rate by type number. The pump type is selected according to the conditions in the characteristic curve diagrams. When the change of head is large, or when the head changes significantly during the pump operation, it is suitable to use mixed flow axial flow pumps with a small flow rate change in response to a change in the actual head of the head curve. On the other hand, when the change of flow rate is large, or when the flow rate changes significantly due to a change in demand during the pump operation, a centrifugal pump with a small head change in response to flow rate fluctuations is suitable because the slope of the head curve is gentle. When the suction head is large, double suction rather than single suction is suitable, but a vertical pump is advantageous over the double suction pump under the conditions of the same discharge rate and the same number of rotations. Let me show you the characteristic curve of the pump. The pump capacity is determined by the specific speed and type number that determine the type of pump. Let's take a look at the following graph as an example. The horizontal axis corresponds to the flow rate, and the total head, shaft power, and efficiency are taken on the vertical axis. The flow rate is then matched to indicate the total head curve, shaft power curve, and efficiency curve, respectively. Therefore, if you read each value of the intersection of the vertical line and each curve at any flow point of the horizontal axis, you can figure out the total head, shaft power, and efficiency of the pump for the flow rate. The point at which the flow rate in the lateral direction meets each point in the longitudinal direction becomes the pump operation point at that time. When the head is large, the flow rate decreases, but when the head is small, the flow rate increases. The shaft power increases in proportion to the increase of the flow rate, and the efficiency increases with increasing flow rate and then decreases again after passing the highest point. As shown in the characteristic curve diagram, when a flow rate of 100 cubic meter per hour is transmitted, the efficiency is about 89%. And when a flow rate of 60 cubic meter per hour is transmitted, the efficiency is about 72%. Periodic inspection refers to the regular inspection and repair of equipment and facilities. According to the inspection method, it is divided into a status check, measurement, testing, and overhaul, and according to the equipment, it can be classified into either the pipeline part or facility part. First, let's look at pipeline facilities. The inspection of pipeline facilities is carried out by patrol operations using vehicles. Before starting the inspection, you should secure the necessary machine tools and drawings and figure out the facilities to inspect other facilities around the pipeline together. Let's take a look at the valve chamber. There is the sluice valve, blow-off valve, air valve, and pressure-reducing valve in the valve chamber. The person in charge of the inspection and maintenance should have full knowledge of the features and operation methods of these valves to check the operation status. If the valve chamber is located on the road or sidewalk, safety measures should be taken before inspection to prevent vehicle and pedestrian accidents. The overhaul of air valves and valve gearboxes are carried out in accordance with a quarterly plan and can be changed considering the site conditions if adjustments is necessary. If replacement is urgent due to the loss of air valve functions or damage to valve parts, a work plan can be established to implement the planned maintenance. Next, let's take a look at the facility part. Water supply facilities include intake, water purification, pressurization, water distribution, measurement and control, and monitoring and control facilities, and there are numerous specifications and types of these facilities. For example, the intake facility has various items and types, such as pumps, centrifugal, mixed flow, axial flow, submersible, motors, valves, butterfly, gate, ball, screens, vacuum pumps, surge protection facilities, safety valve, air chamber, pneumatic, hydraulic equipment, flow meters, electromagnetic, ultrasonic, pressure gauges, Bourdon tube, load cell, and water level gauges, ultrasonic, laser, etc. The actual inspection is possible only if you have an understanding of the basic operating principles, features, and operation methods of these water supply facilities. Looking at the periodic inspection procedures, we first conduct the overhaul of major water supply facilities such as pumps, motors, chlorine and chemical injection facilities, and continuous water quality monitors. The plan for facilities subject to overhaul and implementation schedule are set and carried out accordingly. In addition, it can be changed when the detailed process is established, when the adjustment of the implementation plan is needed considering the site conditions. After the inspection is completed, the overhaul results, including the overhaul period, implementation scope, overhaul contents, and the overall conditions of the facilities need to be recorded, and the result reports also need to be prepared when commenting on the monthly performance. Let's learn about the maintenance of pumps. Pump maintenance refers to a series of methodical activities to maintain the normal function of a pump through maintenance checks, overhaul, and efficiency and vibration measurement, and to improve and manage performance to ensure operations with high degrees of efficiency and performance. Pump maintenance checks can be divided into routine inspections, periodic inspections, and general maintenance. The routine inspection is carried out at least once a day or frequently by an operator on duty. The periodic inspection is subdivided into status check, measurement testing, and overhaul. The status check is to examine the operating conditions and abnormalities of the facility in operation with the naked eye or a portable measuring device. The measurement testing is to analyze the operating status and trends of operating facilities with the use of advanced equipment and includes vibration measurement, precision vibration analysis, and efficiency measurement. The tasks of the overhaul are to temporarily stop the use of the facility and disassemble it to perform an inspection, measurement, testing, and commissioning for the smooth operation of the facility. The general maintenance includes the tasks of small-scale repairs that occur during routine inspection, status check, and measurement and testing operations, partial overhaul, and replacement of consumable materials. The main elements for valve inspection checks includes corrosion and damage status, leaks, and operating conditions. In particular, a valve that does not operate frequently requires inspection to check if bypass control is possible, and it needs to operate from completely closed to fully opened to prevent sticking so that water can be effectively prevented or discharged in case of the suspension of the water supply. When operating the valve, make sure to operate it slowly so that the degree of valve opening does not exceed 5% at any time, and to check the noise, vibration, flow rate fluctuations, and water pressure variations. The following photos show examples of damage found during the valve status check operations. The air valve is an auxiliary facility that regulates the amount of free air trapped in the pipeline, ensuring the flow of water in the water supply system, and is affected only by the conditions of the system as an automatic device. Moreover, the air valve is used as a component of the fluid supply and distribution system, along with other control facilities such as shutoff valves, filters, and flow regulators. Therefore, when designing a pipeline system, the size, type, and an installation location of the air valve must be considered. When an air valve is designed appropriately in the water supply system, hydraulic problems due to an air accumulation and an air movement rarely happen. However, in the case of inappropriate design, air release cannot be controlled due to the over-orifice, causing hydraulic problems. For example, when using a large diameter air valve, air is released at high speed through the orifice even with a small pressure difference. When using a large air valve which is unsuitable for the process, air released through the orifice can cause a high-speed flow of air and water. In the air valve operation modes, the air valve is usually used for inflowing and releasing air in the pipeline according to the conditions of the water supply system. Moreover, the air valve can be used for releasing air or cutting off the air inflow. The air valve is also used for inflowing air, cutting off or controlling air release. These latter two modes are used for special purposes. Whether the air valve intakes or exhausts depends on the pressure. A low-pressure air valve is used for exhaust and intakes a lot of air in large flows. When the pressure inside the pipeline is below the atmospheric pressure, the air valve intakes air. On the other hand, the high-pressure air valve intakes air below the atmospheric pressure and exhausts air even at normal pressure. Next, the possibility of air inflow into the pipeline. When air is not completely removed before the pipeline is filled, and when air is not sufficiently exhausted due to absence of an air exhaust device before a non-return valve is open, a considerable amount of air can be introduced into the pipeline. It has been found that air can be introduced from the pump suction side due to the vortex, which can lead to 5 to 10% of the flow rate into the pump suction side. This introduced air can lead to serious effects such as vibration, corrosion, and the reduced efficiency of pumps, as well as problems in the pipeline. Air can be introduced into a pump gland packing unit, and dissolved air can bubble at the point where the pressure in the pipe is reduced, and air can be generated inside the pipe. When installing air valves, an automation system should be considered for air exhaust valves and installed for easy periodic inspection. In a free zone, it is best to install an air valve in the valve room below the freezing line, and the valve room should be properly ventilated and drained. The unventilated valve room is pressurized while releasing air, which causes serious negative pressure when air enters the pipeline. Moreover, when the valve is installed at an angle, since friction with the float valve occurs in the flow valve guide, the capacity of the absorption and exhaustion can be degraded. Therefore, it must be installed vertically. Next, let's take a look at the overhaul of the air valve. First, the terms related to air valve overhaul. The air valve room as the valve for pipeline protection improves water flow capacity by removing air in the pipeline, and is a space reserved for maintaining the valve, which prevents amplification of water hammering. Oxygen concentration is measured to prevent suffocation accidents in the valve room. This table shows that the effects on the human body according to the concentration of oxygen in the atmosphere and elapsed contact time. The checklist should be checked before inspecting the valve room. Before inspection, fully understand and utilize the characteristics, drawings, specifications, and instruction manual of the facility. And before maintenance, for maintenance, a valve room checklist, status table, measuring equipment, air equipment, and consumable materials for regular use are carried out. The following tools and equipment are required to inspect and measure the inside of the valve room. As a precaution during inspection work, inspectors wear individual safety protective gear before inspection and prepare smartphones for inspection, technical data maintenance manuals, drawings, previous maintenance records, tools and measurement equipment. Next, in accordance with the inspection implementation standards for each facility, inspections must be carried out for each list, and the results must be recorded in detail in the facility management system using a smartphone for inspection. The inspector performs maintenance work if minor maintenance is necessary for the valve in operation during inspection. Let's take a look at the main parts of the air valve during overhaul. The air valves used in Korea are of the double orifice type and the rapid type. The double orifice type has 2 inlet and outlet ports for air, and the rapid air valve has 1 air inlet and outlet. The principle of operation is the same, and although a double orifice air valve is not currently produced, it can be seen in existing pipelines. The air valve consists of 8 parts: valve body, float valve, flow valve guide, flow valve, valve seat, lid, cover, cupper, bolt, and nut. So let's take a look at the disassembly of the air valve and rapid type. If the air valve room is near the road, place a rubber cone for safety. If there is water inside the valve room, install a water pump to drain the water. After measuring the oxygen concentration, if it is within the effective concentration level, enter the valve room. Next, close the water drain valve installed between the main pipe and the air valve. After disengaging the air valve lid using a spanner, press the flow valve and the float ball to completely remove the residual pressure. Disassemble the attached lid with a driver and a rubber hammer. Disassemble the flow valve guide inside the air valve. After removing scaling and foreign substances from the flow valve and float ball with a brush and scraper. While assembling in the reverse order of disassembly, clean by overflowing the turbid water inside the air valve. When water is flowing, open the valve slowly to fill the water gradually and check for leaks in the normal operation. Tidy up and finish after draining the water from the valve room floor. Next, let's take a look at the butterfly valve. For a manual butterfly valve, a circular disc is used as a rotary action valve whose closing element rotates 1/4 turn. There are two types of these valves: concentric butterfly valves and eccentric butterfly valves. The concentric butterfly valve has a simple disc in the center of the valve body. It opens and closes simply to block the water. It is made of cast iron or other inexpensive metal and lined with rubber or polymer. The eccentric butterfly valve is designed for throttling, and the disc is eccentrically installed in the center of the valve body. The disc in this valve does not interact with the seat until fully closed, making it suitable for automated throttling. The checklist should be carried out before inspecting the butterfly valve. Before inspection, fully understand and utilize the characteristics, drawings, specifications, and instruction manual of the facility. And before maintenance, a valve room checklist, status table, measuring equipment, air equipment, and consumable materials for regular use are carried out. The following tools and equipment are required to inspect and measure the inside of the valve room. A taper roller bearing and solid lactic oil is required. Let's begin the overhaul. First, in order to calibrate the butterfly valve, turn off the power at the motor control center, and then disassemble the actuator. At this time, since the actuator load is heavy, it must be lifted with a chain block using a tripod or a hook. After disassembling the connection cover between the actuator and the reducer, disassemble the cover and the reducer gear. Separate the upper cover and disassemble the worm gear shift. At this time, the worm gear cannot be disassembled unless the lower bearing is disassembled, since there are upper and lower tapered roller bearings. Inspect damages by checking the proper dimensions of the worm gear. At this time, when the damage is more than a reference value, assemble after reprocessing. Assemble in the reverse order it was disassembled. The engaging area of the gear is assembled after applying the grease. After assembling, check the operation manually. When normal operation is confirmed, power on, tidy up and finish. The operation test of the gate valve of the water pipeline should be conducted within the range of 5%. The overhaul is mainly carried out by inspecting the inside of the gearbox due to the pressure on the pipeline. Open the valve room cover and inspect visually. The purpose of inspection is reapplying the grease inside the gearbox. Let's overhaul the gate valve on the pipeline. If the air valve room is near the road, place a rubber cone for safety. If there is water inside the valve room, install a water pump to drain the water. Measure the oxygen concentration with an oxygen concentration meter and enter the valve room if it is within the effective concentration levels. The gate valve room is often installed with an auxiliary pipe to help work be carried out safely. After carefully disassembling the gate valve gearbox cover with a spanner, remove foreign substances and grease. Check the inside of the gearbox and the condition of the stopper inside. Fill the worm gear section with grease and cover it. Finally, tidy up the surroundings and finish. These are the tools and equipment for the pump overhaul. This is the water intake pump to be overhauled. In order to prevent safety accidents, rack out the breaker. Close the maintenance valve. Close the inlet valve. Drain the water inside the pump. Disassemble the water level sensor. Remove the coupling between the pump and the motor. Disassemble the bearing temperature sensor. Remove the bolt diagonally. Prior to removing the bolts with different depths for each part are marked to reduce human errors from the reassembly process. Remove the bolt diagonally. Disassemble the bearing housing bolts. Remove the bolt diagonally. For parts that cannot be easily opened with power tools, carefully use a hand tool. Turn the jack bolts to give space between the upper and lower casings. Hang the correct size sling bar, lift it slowly with balance, and move it to the workbench. This shows the upper casing moved to the workbench. This shows the lower casing from which the upper casing has been removed. After balancing the left and right sides using the sling bar and chain block, disassemble the impeller shaft as This shows the impeller shaft which has been moved to the workbench. When there is a lot of scaling, it needs to be disassembled and cleaned. In order to prevent perturbation during coupling removal, fix the impeller shaft to the workbench. When a part forcibly inserted cannot be easily disassembled, it can be easily disassembled by heating. coupling for safety in consideration of possible falling during coupling disconnection. Disassemble the coupling and shaft using a hydraulic gear puller. Separate as much as you can with a hydraulic gear puller. The last remaining part is disassembled using a general gear puller. This shows the impeller shaft where the couple ring is separated. The bearing cover should be disassembled without heating. Check the condition of the bearing. Check the position before disassembling the bearing. Disassemble the lock nuts. Check the position before disassembling the bearing. Use a gear puller to disassemble the bearing housing. Disassemble the packing gland. This shows the separated bearing. This shows the shaft where the bearing is separated. Measure the impeller mechanical seal length. Replace the seal if it is old and suffering severe internal contamination. Disassemble the wear ring. A lot of dust is generated during work, so it should be done outside where possible. Measure the impeller wear. Measure wear ring wear. This is the view of the workplace. Clean the lower casing. Clean the shaft. Process the gasket. This shows the processed gasket. This shows the cleaned upper casing. It is being cleaned. The gasket is being processed. This shows the cleaned shaft. Since it is weak against impact due to the characteristics of carbon fiber, carefully assemble it. Check the tension of the spring. This shows the completely assembled mechanical seal. Since it is weak against impact due to the characteristics of carbon fiber, carefully assemble it. Measure the wear of the packing gland. Replace the packing gland due to wear and contamination. Since it's weak against impact due to the characteristics of carbon fiber, apply sufficient grease and assemble slowly. As it is weak against impact, assemble it so that no impact is applied. This shows the assembled packing gland. Since it's weak against impact due to the characteristics of carbon fiber, apply sufficient grease and assemble slowly. This shows the assembled packing gland. Assemble the bearing housing. For smooth assembly, apply enough grease before assembling. This shows the assembled bearing. Assemble the bearing shaft. Heat the bearing for assembling. Assemble in the same place it was previously assembled. Assemble in the place it was previously assembled. Combine the lock nuts. Apply grease to the bearing. Apply sufficient grease to minimize internal friction. Assemble the bearing housing cover. The coupling is heated to expand and then combines with the shaft. Assemble in the place it was previously assembled. Move the impeller shaft. Using a horizontal ruler, level and settle it to the proper position with precise control. This shows the impeller shaft properly settled. After cleaning and mounting surface, attach the gasket, apply the gasket bond, and apply the upper casing. Assemble the upper casing. Tighten the blots diagonally. Check and confirm for perfect fastening. Since it is weak against impact, carefully assemble it. combine the water level sensor. This is the process of assembling auxiliary equipment, such as sealing water pipelines and overflood sensing devices, after completing the assembly of the pump body. Open the valve to fill the inside of the pump with water. Check for leaks. When there are no leaks, verify the assembly. Measure the alignment. Install the transceiver fixture. Install the transceiver. This shows the installed alignment measuring instrument. Alignment is done to ensure that the transmitter and receiver position enters the measuring range. Enter the parameters. The specifications required for measurement are being measured. These are the entered parameters. Check the center by adjusting the location of the transceiver. Measurement is made by moving shafts on both sides to which the receiver and transmitter are connected by 90 degrees and then moving them back to their original positions. In most cases, errors occur due to overhaul and soft foot and shims at the machine, motor feet, and the coupling are used to reduce the margin of error. The current pump motor alignment is as shown. Change the motor position using the positioning screw on the base. When the alignment is good, the work is finished. Join the coupling. Assemble the bearing temperature sensor. Commissioning is prepared after the completion of the pump overhauling procedure. Check that the bearing temperature is good. Measure the drive end and non-drive end of the pump and motor, and measure the vertical, horizontal, and axial directions. It is checked whether the measured vibration value is within the proper range.